Hello students, welcome to EPG Pathshala. Hello students, welcome to EPG Pathshala. In this module, we shall be discussing the wastewater characteristics of electroplating industry and wastewater characteristics of tannery industries. Both industries are very important industries, and large quantities of wastewater are generated by these industries. So, again, for the treatment and for legal requirements, the knowledge of wastewater characteristics is essential, as well as based upon the knowledge of the characteristics, we can decide whether primary treatment is required, whether secondary treatment is required, whether advanced treatment is required, or any two of these treatments are required, or all these treatments are required for the treatment of wastewater of these industries. The learning objectives of this module are to know about the wastewater characteristics of electroplating industry and to know about wastewater characteristics of tannery industry. Let me start with electroplating industry. What is electroplating? Electroplating is the process to change the surface properties of an object to make it abrasion and wear and tear resistance, corrosion proof, glossy and aesthetically better. In electroplating, a thin protective metallic layer is deposited onto a prepared metallic surface by electrochemical process. Environmental concerns of electroplating industry. Certain factors are largely responsible for extensive pollution from electroplating industries, which include their existence in very large number in a particular area, their sporadic distribution and small scale operations, and poor housekeeping, lack of space for installing waste treatment facilities, in view of their being located mostly in areas of high commercial activity or in a composite industrial complex. The high cost of treatment of wastewater, particularly for the micro and small scale units. Process and chemicals used in electroplating cleaning, stripping or pickling, electroplating, post treatment, conversion coating, phosphating, sealing, metal coloring. This table shows different types of platings and waste generated. During brass plating, cyanides of sodium, copper and zinc, sodium carbonate, alkaline pyrophosphate, tartarate are the chemicals used as electrolyte and additive, and during brass plating, cyanide vapors are generated as waste. During bronze plating, cyanides of copper and sodium are used, and again cyanide vapors are generated as waste. During cadmium plating, cadmium cyanide, sodium carbonate and sodium hydroxide are used, and cadmium vapors are generated as waste. During chromium plating, chromic acid, sulfuric acid and sodium fluoride are used, and hexavalent chromium vapors are generated as waste. During copper plating, copper cyanide, sodium hydroxide, sodium carbonate, copper sulfate and sulfuric acid are used. Cyanide vapors, acid mist, hydrogen fluoride vapors are generated as waste. During gold plating, potassium gold cyanide, potassium hydroxide and potassium dichromate are used, and potassium cyanide vapors are generated as waste. During silver plating, silver potassium cyanide, copper cyanide, potassium cyanide are used, and cyanide vapors are generated. During nickel plating, nickel sulfate, nickel chloride, boric acid, sulfuric acid are used, and nickel sulfate fumes, acid mist, hydrogen fluoride vapors are generated as waste. During palladium plating, palladium chloride, ammonium chloride and hydrochloric acids are used, and ammonium vapors and acid mist are generated as waste. During platinum plating, hexachloroplatinum, ammonium phosphate, ammonium hydroxide, dinitrosulfatoplatinate 2 solution and sulfuric acid are used. During this platinum plating, platinum vapors and ammonium vapors are generated as waste. During rhodium plating, rhodium sulfate and sulfuric acid are used, and rhodium vapors and acid mist are generated as waste. During zinc plating, chlorides of zinc, potassium and ammonium, boric acid, zinc cyanide, sodium cyanide, etc. are used, and zinc chloride gas, ammonium vapors, alkali mist are produced as waste. From this table, it is evident that a large number of inorganic chemicals are used during the electroplating process, and many of them end up in the wastewater, as well as a number of them end up in the air in the vapor form. This table shows the wastewater discharge standards for electroplating industry. The pH of treated effluent of electroplating industry should be in the range of 6 to 9. Temperature of wastewater should not be more than 5 degrees Celsius higher than the ambient temperature of the receiving body. Oil and grease should be less than 10 milligram per liter. Suspended solids should be less than 100 milligram per liter. Cyanide as CN should be less than 0.2 milligram per liter. Ammonical nitrogen as nitrogen should be less than 50 milligram per liter. Total residual chlorine should be less than 1 milligram per liter. Cadmium should be less than 2 milligram per liter. Nickel should not be more than 3 milligram per liter, and zinc should not be more than 5 milligram per liter. Hexavalent chromium should be less than 0.1 milligram per liter. Total chromium should not exceed 2 milligram per liter. Copper less than 3 milligram per liter. Lead less than 0.1 milligram per liter. Iron less than 3 milligram per liter. Sulfides less than 2 milligram per liter. Sulfates less than 400 milligram per liter. Phosphates as phosphorus should be less than 5 milligram per liter. Total metal content, combined concentration of all the metals should be less than 10 milligram per liter. Dear students, here you will find that in case of electroplating industry, mainly these are the metals and inorganics which are important, whereas in case of tannery industry and sewage, this was the BOD and COD and suspended solids which were more important. So, from the comparison of these two industries, you can conclude that for these two different type of industries, different kind of treatments are required. For a electroplating industry, certainly activated sludge process or biological treatment is not important. Here we require advanced treatment for the removal of these metals. This table shows the different method of treatments that can be used for the removal of different pollutants from the electroplating wastewater. For the removal of cyanide from the electroplating wastewater, we can use chlorination, ozonation, electrolysis and ion exchange methods. For the removal of hexavalent chromium, we can use reduction to trivalent chromium and then precipitation. Cementation process can also be used. Then precipitation as barium salt can also be used, or ion exchange approach can also be used for the removal of hexavalent chromium. For the removal of other heavy metals, we can use neutralization and precipitation as hydroxide. Dear students, you know that hydroxides of most of the heavy metals are not soluble in water. So, if you increase the pH of wastewater, hydroxide ions will increase, and then there is a very strong possibility that the heavy metals may get precipitated as metal hydroxides. The other approach for the removal of heavy metals may be destruction of complexes and precipitation. This approach is mainly used for the removal of complex metals, and we can use ion exchange approach also. Dear students, the discussion on each and every technique is beyond the scope of this lecture. I will suggest you please read about each and every technique that can be used for the treatment of electroplating industry. You will get a better idea of the use of techniques at the industrial level. Now, let me come to the tanning industry. Tanning is the process of animal skins and hides to produce leather. Almost 90% of the tanning capacity in India is concentrated only in 4 states. The major leather producing units are clustered in Tamil Nadu, West Bengal, Uttar Pradesh and Punjab. You know, the Kanpur area of Uttar Pradesh is well known for the tanning industries and the pollution of river Ganga caused by them. India has a large cattle population and holds 10% of the global raw material, that is hide and skin, accounting for 2% of the global trade. Here the list of leather manufacturing process and inputs is given. The various steps involved in leather manufacturing include soaking, liming, deliming and batting, pickling, tanning. Tanning can be of several types like vegetable tanning and chrome tanning. This table shows the water consumption in individual process operations which we have discussed just now. Pre-tanning include several operations, and these operations are soaking, liming, deliming, batting and pickling. During soaking, 7 to 9 cubic meter per ton of raw hide wastewater is generated. During liming, 9 to 15 cubic meter per ton raw hide wastewater is generated. During deliming and batting, 7 to 1100 cubic meter per ton raw hide wastewater is generated, and during pickling up to 1 cubic meter per ton raw hide wastewater is generated. Tanning is again of 2 types, chrome tanning and vegetable tanning. During chrome tanning, 3 to 4.5 cubic meter per ton raw hide wastewater is generated. During vegetable tanning, 1.7 to 2 ton cubic meter per ton raw hide wastewater is generated. During post tanning process, 7 to 13 cubic meter per ton of raw hide wastewater is generated, and small amount of wastewater is generated during the finishing step also. So, in total about 34 to 56 cubic meter per ton raw hide wastewater is generated, or from this table it is clear that large amount of wastewater is generated. The major water pollutants generated by the tanning industries are salts, organic matter, sulfides and chromium. This table shows the pollution load discharged in effluents from individual processing operation. We will be discussing only the total pollution load coming from different steps. The tanning industry wastewater has 83 to 149 kilogram per ton raw hide pollution load of suspended solids. COD is 145 to 231 kilogram per ton raw hide. BOD is 50 to 86 kilogram per ton raw hide, and chromium is 3 to 7 kilogram per ton raw hide. Ammonical nitrogen is 4 to 6 kilogram per ton raw hide. Total gel-dal nitrogen is 12 to 18 kilogram per ton raw hide, and chlorides are 137 to 200 kilogram per ton raw hide, and sulfates are 52 to 110 kilogram per ton of raw hide. From this data, it is evident that tannery industry wastewater is highly loaded with the pollutants, and their treatment is very important before their discharge, whether in sewers, whether in some water bodies or whether on land. Central Pollution Control Board standards for discharge of tannery effluents are given in this table. The standards are different for inland water bodies, for public sewers, for land for irrigation as well as for marine coastal areas. The suspended solid for inland surface water should be less than 100 milligram per liter, and for land it can be up to 200 milligram per liter. BOD for water bodies should be less than 30 milligram per liter. pH should be in the range of 6 to 9 wherever you dispose. Chloride should be less than 1000 milligram per liter for inland surface water disposal of treated effluent of tannery industry. Hexavalent chromium should be less than 0.1 milligram per liter for inland surface water disposal. Total chromium should be less than 2 milligram per liter for inland surface water disposal. Sulfides should be less than 2 milligram per liter for inland surface water disposal. Boron should be less than 2 milligram per liter for inland surface water disposal, and oil and grease should be less than 10 milligram per liter for inland surface water. Dear students, I have discussed the standards only for inland surface water. You are suggested to look for the standards for other places of disposal also. The treatment of tannery wastewater include following steps: mechanical treatment, primary effluent treatment, secondary effluent treatment, and then post purification, sedimentation and sludge handling. Dear student, in this module we have studied the wastewater characteristics of the electroplating industry, and on the basis of characteristics we have found that in case of electroplating industry, these are the inorganic salts, cyanide and heavy metal which are very important, and based upon these characteristics we can decide that what kind of treatment is required. We also studied different standards set by Central Pollution Control Board for the disposal of electroplating industry wastewater. In the second part we studied about tannery industries. We also studied that what is the water requirement for different processes, and based upon that we concluded that large quantities of wastewater are used in the different steps of tanning industry, and a large volume of wastewater is generated. Whatever wastewater is generated by the tanning industry, that is heavily loaded with the pollutants, and this is having a very high level of BOD and COD. Standards have been given for the disposal of tannery industry different for different places. There are different standards for inland, there are different standards for land, and there are different standards for sewage disposal or marine disposal, and in the end we have seen that what kind of treatment is used for the tanning industry. I hope you enjoyed this module. Thank you.